Section 8.2 on volume is fairly straightforward. So again, volume of a right prism. We notice that volume of right prism, all we need to do is worry about the area of the base, multiplied by the height. So we notice that if we wanted to have a volume of a prism of height 10 centimeters, and side length whoops. And a base that is a regular polygon with 6 sides of length 4 centimeters is given by area of the base multiplied by the height and so we know that if it has 6 sides of length 4 centimeters, we know area of the base is equal to 6 times, we can break up into 6 triangles of base 4 centimeters, and the height of each of those is going to be 2 radical 3. So we wind up getting, whoops, we have to be careful, 1/2. So we're going to wind up getting 6 times 4 radical 3 is 24 radical 3 square centimeters. And so that's going to be approximately 24 times the square root of 3 is 40, approximately 41.6. And so now we notice that if the height is 10 centimeters, we know the volume is going to be approximately 41.6 41.6 square centimeters multiplied by 10 centimeters, and so we get approximately 416 cubic centimeters. And then we always have to be careful that area should be in square units, volume should be in cubic units. So if you end up getting a volume of 416 square centimeters, something has gone wrong. So we actually notice that for volume of prisms, we can be a little more flexible. We notice that if we were just told that we have a prism has a base of area equal to 30 square meters and a height of 4 meters, the volume is just going to be that 30 square centimeters times the height of 4 meters, and we're going to get 120 cubic meters. Again, we just have to be careful that if we're told that it's a specific type of polygon with a particular side length, we can't just assume that the area is something nice. One other type of solid we want to think about is prisms and pyramids. Turns out that if we have a pyramid with a square base, of side length d, then the volume of the pyramid turns out to be 1/3 times d squared times the height. So we should say it has side length d and height h. So we notice that if we had a specific case, so let's just say a square-based pyramid has a height of 12 meters and base that is 4 meters on a side, V is going to equal 1/3 times that 12 meters times the 4 meters squared is going to end up giving us 64 cubic meters. So the formula for volume of a pyramid, pretty straightforward. And similarly, volume of a cone is equal to 1/3 pi times the radius squared times the height. And so basically 1/3 area of the base times the height. And so a cone of radius 6 centimeters and height 4 centimeters has a volume equal to 1/3 pi times 6 centimeters squared times 4 centimeters, which gives us 12 times 4 is 48 pi centimeters cubed. So an interesting side note, we're not going to worry about this too much for the moment, is the idea that the surface area is given by area of the base plus the lateral surface area and turns out that's going to be pi r squared plus pi times the radius times script L, which is called the slant height. L is the slant height. And this we can get from Pythagorean theorem. We notice that for the cone we just did, we said that it has a radius of 6 and a height of 4. We notice that that means that we're looking at 6 centimeters, 4 centimeters. The slant height has to be the square root of 4 squared plus 6 squared centimeters. And so the slant height turns out to be the square root of 36 plus 16 is 52. And so we know that's going to be approximately 7 point something. 7.2 centimeters. And so we wind up getting, for that cone we just did, we had found that the volume was 48 pi centimeters cubed. We noticed that surface area, so let's stick with radius is 6, height is 4. So for r equals 6 centimeters, h equals 4 centimeters, we know that the surface area is pi times 6 centimeters squared plus pi times the radius is 6 centimeters times that slant height of 7.2 centimeters. And so we end up getting 36 pi square centimeters plus that'll be 43.2 pi square centimeters. And so we get 79.2 square centimeters. 79.2 pi square centimeters. And so again, we'll turn that into a number. So that's approximately 248.8. Square centimeters. And we can do something similar with pyramids. We notice that, again, we have to worry about the slant height, same kind of idea. We notice that if we had a pyramid and we wanted to know what its area was, its surface area was, we'd have to think about if we had, say, 8 meters by 8 meters by a height of, let's make it 3 meters. We notice that we would basically look at a cross section. We would get 3 meters tall. We get a triangle that was 3 by 4, and then the slant height would wind up being 5. And so we notice that the surface area of this would be 8 meters squared plus 4 times the area of the triangle. We get 1/2 times 8 meters times 5 meters for the slant height. And so we would get 64 square meters plus 80 square meters, 80 square meters. And so we would get 144 square meters. And if we were curious, the volume would turn out to be 1/3 times the base times the height. So we have that 1/3 times 8 meters squared times 8 meters quantity squared times the height of 3 meters. And so we would end up getting 64 cubic meters. And so you'll notice that volume and surface area are often very distinct. You can have a very large surface area and a very small volume. Just depends on how the object is shaped.